Hello. In this lecture, we are learning the motional EMF. So, what the topic today? That is the motional EMF. What the motional EMF? Just suppose we are taking one of the rod and that is crossing the magnetic field lines. Then what will happen? There will be the electromotive force, that is EMF, that will develop at the end of the rod. That is the motional EMF. Now, what the related formula? Just suppose we are taking the magnetic field here. This cross, this is the magnetic field. As we know, this is directed into the board, and having intensity we are taking B here, and this is the uniform magnetic field because this is equidistant. And then what we are taking one of the metallic rod like this, and we are taking another metallic rod like this. So two parallel rods we are taking, and then we are placing one of the wire like this one. Just suppose this is the PQ, one wire we are taking, and this can slide, it can slide. So what we are taking, just suppose we are applying here, we are giving here one of the constant velocity. So here this is the velocity that we are taking the constant, and then if it will move here. And one more thing, here we are taking the length of this wire. What the wire we are taking, this is the length, and the V is the velocity. And you should know here what the angle between the velocity and the length, that is the 90 degree. So here this is the case, the angle between length of the wire PQ and the velocity, that is the 90 degree. After that what we are doing, just suppose this is moving here, this is moving here, and this is covering a small distance we are taking here, that is the dx. This is the small distance dx. In time duration, that is the dt. In time dt, this rod is covering the distance dx. So you should know, if this rod will shift here, so what will happen, the magnetic field lines which are directed into the board, and the length, this is L, it will cross the magnetic field lines, because the field lines like this and this is going like this. So this will cross the magnetic field lines. So what will happen here, you can see, just suppose initial location we are taking P and Q, and here we are taking R and S. So when the rod will travel here, then it will cover the area, that is the PQRS, or you can say during motion this much area will be changed. And because of this there will be change in flux. And as we know that using the Faraday's law, if the flux will change, then there will be the induced EMF. Okay, so here EMF will induced across this rod. So as we know that flux phi equal to B A cos theta. So B is the magnetic field, A is the area, what the area traveled, and then cos theta, theta is the angle between area vector and the field vector. Here we are taking this much area, so we will take the area vector into the board and the field vector into the board. So theta we will take, that is the 0. So the phi equal to BA, and the cos 0, that is the 1, only BA. Okay, so here if we are taking the, according to Faraday law, what the Faraday law, induced EMF, that is equal to negative of N d phi by dt. If we, this is the N is the number of turns, so here we are taking N equals to 1. And if we are taking this negative is representing the Lenz's law, means using this we can find the polarity of the EMF. So here we are taking only the magnitude, that is d phi by dt. d phi by dt. So here equal to d by dt, what the phi equal to b into a. Phi equal to b into a. Then EMF equals to, induced EMF is equals to, here b is the constant, and what the area. And one more thing, here this will become dA by dt. dA by dt, what the area is changing here. So this is b, and dA, what the dA, this one, this length multiplied by this width, that is dx. So L dx, this be the small area, that is here. dA is what, this is the length and this is the width, this is the L dx. So here dA means L dx divided by dt. So here you should know this is the dx by dt. So dx by dt, this is the instantaneous velocity, dx by dt we can write here. So here what the EMF we are getting, EMF that is equals to EMF equal to B, and the length L and dx by dt is the V. So this is the motional EMF. So this much EMF will induce across this rod E equal to BLV. And very important thing, you should know the length and the velocity. Here we are taking the perpendicular or the 90 degree. It means if the rod is perpendicular to the velocity vector, then the EMF is BLV. If not, the rod is perpendicular to the velocity vector, then you should take the component of length that should be perpendicular to the velocity vector. Okay, so here, so this is the motional EMF formula. Here we are learning only the how to get the magnitude, how to polarity. In other lectures we will discuss. Okay, so here one of the points you should know. Just suppose I'm taking one of the case where the rod is not perpendicular to the velocity vector. Like, just suppose we are taking, this is the magnetic field which is directed into the board, and the uniform. Equidistant means uniform. Like this. Okay. And the intensity we are taking this one B. And just suppose we are taking the rod like this. This is the rod having length L. And here we are taking, this is the velocity vector V. And the angle between the length and the velocity, that is the theta. So here, as we know that to find the motional EMF E equal to BLV, okay, the length should be perpendicular to the velocity vector. If we don't have the length perpendicular to the velocity vector, then we will take one of the component of length that is perpendicular to the velocity vector. So look here, if we are taking this length, so here we can consider, if this is theta, again we can take this theta, because this is the corresponding, this is the parallel lines, and this is corresponding angle. So here this is the length which is making the angle theta with the velocity vector. So it has two components, one L cos theta, this one which is parallel to V, and the second one L sin theta which is perpendicular to the V. So one component, this component here, this component of the length, this will become, this is the L sin theta. Now this is the component of length which is perpendicular to the velocity vector, So to find the motional EMF, we will take this length L sin theta, not the L cos theta, because this L cos theta will not cross the magnetic field lines. Means because of this component the flux will not change and the EMF will not induce. So we will take this length. So what the EMF here? E equal to B V L sin theta. So this is the main formula, E equal to B V L sin theta. If we will take the previous case, what we learn means here like this, the rod was like this and the velocity like this. So this is L, this is V. So what the theta here? Theta equal to 90 degree. If we will place the 90 degree here, so equal to BVL sin theta, sin 91. So it will become BVL or BLV. So the main concept, theta, if the theta is the angle between the length and the velocity, then the formula is BVL sin theta. If 90 degree, then directly BLV. So you should know the motional EMF is BVL sin theta, theta 90 degree, then BLV. And what the component we should take? We should take the component of length which is perpendicular to the velocity vector. So in this lecture, we learn only the magnitude of motional EMF. Okay. In other lectures, we will discuss where the polarity. Just suppose this is the EMF, so definitely there will be the potential difference. So where positive, where negative, means this rod, where it will become positive, where it will become negative, we will discuss in other lectures. Okay. Thank you.